Okay, it's time now to go through the nuts and bolts of drawing a scatter diagram. What you'll see here is I've got two variables, variable 1 and variable 2, and I've got a table of results over here. Now, in order to draw this scatter diagram, I've looked down variable 1's values and found that the highest value is 8, the lowest value is 1, and then I drew out a line and spaced out the numbers up to 8 evenly. In order to work out the scale up here, I looked down the list, saw the highest value was 120 and the lowest value was 10, and then went, okay, so this scale goes up in larger numbers. I'm going to go up in 20s in order to do that. So careful planning of your axes. Look for the largest value is crucial. Axes, not axis, because there's plural. So now I'm going to plot the data. So here's the first data point. It has two values, a 6 for variable 1 and a 40 for variable 2. And I put a cross. Next one has 5 for variable 1 and a 45 for variable 2. 3 and 82. 7 and 15. Now, from looking at this table, you might have already seen that high values for variable 1 tended to have low values for variable 2. So when one is high, the other is low. And you might be guessing you're going to get something like this for a line. So far it looks that way. Now, what you've got here is not really enough information to draw a scatter diagram. You should have a lot more than this. Ideally, you should have at least 50 points if you want to make a really good one. But for the sake of time, I'm going to reduce it. 8 and 10. 1 and 100, 1 and 120. You can see here that there isn't a specific link. Just because it has a 1 here, it doesn't have to have an exact value here. It can be a range. And you'll see with 2 and 100 that two different variable 1 values can have the same score here. Now, if you remember back to when we looked at people and we looked at height versus weight, what we saw was that some people are just a bit taller and a bit heavier than typical, like the world's tallest man didn't fit our pattern. That's okay. Data is not, when you collect real life information, won't fit a perfect line. 3 and 105. 2 and 110. 4 and 70, 4 and 55. So the key things are plan your axes so that you've got nice evenly spread out values. Use the highest value to do so. Then take the pairs and plot them carefully. At this stage, you should be looking at a pattern here and trying to describe what you have. So what do we have? Do we have a correlation? We do. Is it positive or negative? Well, it's definitely negative. Now, think back to our discussion of correlation. Is it perfect? Are they all exactly in a line? Is it strong? Are they tightly along the line? Or is it weak? Well, let's use the pen here to kind of guess where the line would go. You can see it covers most of them. So I'm going to say that is strong negative correlation we've just found. So plan the axes, carefully plot the points, and then look at and describe whether you've got a correlation or not. And this is something you're going to have to practice a few times. So I suggest now you look up some examples in the books and you make some diagrams yourself. And actually you'll find the axes are the crucial bit. You can also use things like Microsoft Excel to plot charts for you. Now, what we're going to look at next, within the same topic, is this thing that I keep drawing. You see these lines here that I've drawn continuously through the topic in order to show the behaviour. Oh, that line is really important because it's trying to show what the overall behaviour is. When we looked at height and weight, I drew one of these lines in red and we noticed there were outliers. But in general, we had a strong bunching of data around this line. Now, what you're trying to do with the line is describe how the data behaves exactly. Now, some points will vary off your line, but you're trying to fit it down the middle of your data. So your line that best fits the description of the data. So it's called a line of best fit. Now actually, lines of best fit can be calculated in very complicated manners. And the aim is actually to reduce the distances above and below the line to as small as possible. Now a rule of thumb you might hear is get half the points on either side. That's not a bad way of guessing. But I'm going to try and make sure that not only do I have half the points on either side, but my lines are as short as possible. And it won't matter if I'm not exactly accurate. There's where I think the line of best fit is. In fact, I need to carry it on further. Now, I stopped my line of best fit here at 0, and I tried to finish it off all the way down to 8 before I hit the axis. Can you see? What I've tried to do is make these lines here overall as small as possible. I couldn't get rid of this big one here and this big one here, because if I'd done that and perhaps gone like over here and drawn a different line of best fit, it would have made this one shorter, but these ones all very long. Okay, next thing for you to bear in mind is the line of best fit that you will draw will always be straight. Now, why did I stop at the ends? Well, that's the data range. And it's very important that you don't go past where the data lies. Let me show you why. Here's a chart that looks at the growth of plants and the other variable, as well as the height of the plants, is the amount of water they've been given. Now, as you can see, there is quite a strong positive relationship here between my plants and the growth. So, if I was to draw a line of best fit, I could confidently go through from here, level with the first cross, up to the end. I might even then say, let's extrapolate beyond that. So continue out beyond the data. Now we do this a lot in life to predict behaviours. But let's think about our plant. And here is a really bad drawing of a plant. What happens if we give it way too much water? Well, the plant won't eat ice cream, but it will drown. So actually, once you get past a certain point, the plants die. And so the graph doesn't continue to rise up, it plummets down until they're all dead. And there's a tipping point, therefore, which you should not water your plant past. So, extrapolation is dangerous. So your line of best fit should not extend beyond the range of observed values. So if the lowest value is here and the highest value is here, your line of best fit can only cover between those 2 points. Now this becomes crucial in a minute when we look at using lines of best fit. I'll let you take a break for a minute and then we'll look at that in the next part.